Scientists just discovered something pretty alarming about hailstorms. They're not just getting stronger, the hail itself is getting bigger. Extra heat in the atmosphere can turn these icy balls into softball-sized lumps of ice, enough to smash windows, wreck cars, and wipe out crops. The discovery started with a huge storm that hit Paris and other parts of France in 2025. Some hailstones were as small as marbles, and others were about the size of golf balls. When the storm was over, it had caused more than $350 million worth of damage, so scientists wanted to know whether a warmer atmosphere helped make that storm worse. They compared it to dozens of similar storms from the past, asking just one simple question. If the exact same storm happened in a cooler world, would it look different? The answer was yes. The researchers found that in parts of France and Germany, weather that produces hail is now up to 30% more likely to happen now than in the past, and the hail itself can grow much larger. In the most extreme warming scenario, the number of storms capable of producing hail larger than a marble could jump by almost 50% by the year 2100. Even in a more optimistic scenario, where warming is lower, the increase was still huge. The risk of giant hail-producing storms rose by nearly 40%. To understand why that happens, we first need to look at how hail forms. Strong upward winds inside the storm pick up raindrops and carry them high into the atmosphere. Up there, temperatures are well below freezing. The raindrops freeze into small balls of ice. Powerful winds inside the cloud keep throwing those ice pieces upward again and again. Every time they pass through cold parts of the cloud, another layer of ice sticks to them. It's like rolling a snowball. The longer it rolls, the bigger it gets. Now, hear me out. A hailstone less than 1 inch wide usually falls somewhere between 9 and 25 miles per hour. But once hail reaches about 4 inches across, roughly the size of a grapefruit, it can hit the ground at around 70 miles per hour. Some of the biggest hailstones ever recorded have fallen even faster than 100 miles per hour. In other words, it's a real danger hurtling down from the skies. And now, here's the part that matters. Warmer air usually holds more moisture. That extra moisture gives thunderstorms more energy. More energy means stronger upward winds inside the cloud. And stronger winds can keep hailstones floating around longer before they finally fall, giving them more than enough time to grow. When everything lines up just right, the storm can become extremely powerful. Scientists have already spotted some alarming signs, like storms in the United States dropping hailstones as big as softballs. That's about the size of a small melon falling out of the sky at high speed. Let's take a look at some of the most devastating hailstorms that have happened recently in the USA. One of them happened in Allen, Texas on May 19, 2023. That storm dropped hailstones about the size of tennis balls, roughly 2.5 inches across. The damage was concentrated in Allen, but nearby cities like Frisco, Plano, and Lucas were hit too. The icy balls badly damaged roofs, windows, cars, and businesses, and by the time it was over, the storm had caused about $1.3 billion in damage. Another hailstorm hit San Antonio, Texas on April 12, 2016. The largest hailstones grew to the size of grapefruits, about 4.5 inches across. The storm literally tore through neighborhoods, smashing roofs, breaking windows, and destroying vehicles. Around 110,000 vehicles and thousands of homes were damaged or ruined completely. The final damage bill reached around $1.4 billion, making it one of the costliest hailstorms ever recorded in Texas. The costliest hailstorm in Colorado history hit the Denver metro area on May 8, 2017. The storm dropped hail as large as baseballs, about 2.75 inches across. It lasted for a short time, but even that was more than enough. After the storm, insurance companies received more than 150,000 auto claims and over 100,000 homeowner claims. Total losses reached a staggering $2.3 billion. In the spring of 2026, huge thunderstorms rolled across the Midwest. They brought strong winds, tornadoes, and enormous hail. In Illinois, one meteorologist found a hailstone that was about 16 inches around and weighed more than a pound, like a small pineapple. Weather experts have been tracking hail for decades, and nothing like this had ever been recorded there before. Now, this doesn't mean that every thunderstorm will start throwing giant ice spheres at us, but if the conditions are just right, the hail is likely to become way bigger and a lot more destructive than it used to be. The problem is that hailstorms are very hard to study. Most hail forms inside powerful thunderstorms that can be only a few miles wide. That's tiny compared to those giant areas climate models usually work with. It's like trying to study a bee while looking at an entire football field from space. Besides, proving that the changes in weather patterns are affecting hailstorms is even harder. That's why the new study is a big deal. The researchers explain that hail is no longer a rare problem that only affects a few farms in the middle of nowhere. Bigger hailstorms are starting to hit larger areas, like large cities filled with cars, homes, offices, and people. The damage can add up fast. Interestingly, weather change isn't creating these storms from scratch. The same patterns that produced hail decades ago still exist today. The difference is that the atmosphere now contains more heat and more moisture. In other words, the storms don't really show up more often these days, but when they do show up, they hit harder. The interesting thing is that insurance companies started worrying about this years ago. Because a single hailstorm can cause billions of dollars in damage in just a few minutes. Take a large city filled with cars, glass buildings, and solar panels, and now imagine giant ice balls suddenly falling from the sky. Some hailstorms in Europe have already caused losses close to $3 billion from just one event. That's why scientists are trying so hard to understand exactly how climate change affects hail. If researchers can figure out which storms are most likely to produce giant hailstones, weather forecasts could become more accurate. Farmers might get earlier warnings, and cities would have more time to prepare. Some places could even improve methods that try to reduce hail damage before the storm arrives. The new study is also kinda revolutionary. Most climate models have predicted that larger hail should become more common as the planet warms. But predictions are one thing, and real-world proof is another. Experts are now more confident about one thing. When a hailstorm forms, today's warmer atmosphere can help make it more dangerous. There are still a lot of things we don't know, though. One big problem is that hail is not only hard to study but also difficult to track. A tornado can leave a long path of destruction that's easy to examine afterward, but hail is different. One neighborhood might get hammered while another neighborhood a mile away is left unscathed. And if a hailstorm happens in the middle of nowhere, we might not even record it at all. Scientists are still trying to understand exactly what happens inside a thunderstorm while hail is growing. Those processes happen on a very small scale and can change from minute to minute. These days, rain and snow get most of the attention. Too much rain can flood entire towns. Heavy snow can shut down roads, collapse roofs, and leave people without power. But hail is one of the weirdest and most destructive things that can fall out of the sky. Over the last decade, major flooding events in the United States have caused an average of about $4.6 billion in damage every year. Winter storms have been even more expensive, causing roughly $5.1 billion in damage annually. But hail can be just as nasty. And one thing is already clear. A warmer atmosphere gives thunderstorms more fuel, more heat, more moisture, and stronger upward winds. And that change can easily turn an ordinary hailstorm into something much more destructive. People went outside and stopped in wonder. Some gooey stuff was covering the ground. Whitish, gelatinous blobs had turned the outside world into a scene out of a creepy sci-fi movie. This mystery evoked lots of discussion, and experts offered different theories. But it turned out that the situation was even worse than previously thought. The blobs reportedly made the people who came into contact with them sick. But let's start from the very beginning. It was the summer of 1994 in the timber town of Oakville when gelatinous blobs were found on the ground. People thought they had rained from the sky because where else could they have come from? This find caused panic and confusion among the residents of the area. But actually, it was just the first appearance of this gooey substance. Flecks of goo, which were actually smaller than a grain of rice, fell down from the sky several times. The volume was very high, and when they accumulated on the ground and shed roofs, they became visible. Around 10 days after the first occurrence, a newspaper wrote an article about the blobs. Other than that, there seemed to be no other confirmed and official reports about this mysterious substance. Until a National Weather Service employee in the area got a call from an unidentified man in August. The man claimed that some hot, metallic particles falling from the sky had burned holes in his kid's trampoline. Apparently, it was time to examine the Oakville blobs. A hospital reportedly looked at them under a microscope and made a terrifying discovery. The researchers stated that the substance contained human white cells. This encouraged some people to suppose that the blobs were probably concentrated fluid waste from an airplane toilet. This theory was debunked after a spokesperson of the Federal Aviation Administration explained that toilet fluids were usually dyed blue, which gave them the nickname blue ice. Another theory trying to explain the Oakville blobs suggested they had something to do with jellyfish. Some experts agreed that this idea was plausible. Something the size of portions of jellyfish could have been pulled up into the atmosphere and moved to another location during a storm. After all, raining animals is nothing new, but we'll speak about that later. At the same time, 6 events of the Oakville blobs raining down from the sky were reported, which made it hard to imagine jellyfish particles floating around in the sky for so long. On the 20th of August 1994, the New York Times reported that the mysterious gooey substance had once been alive. This article followed an analysis made by the Washington State Department of Ecology. The scientists who had tested the blobs announced that they had found out that the substance contained a number of cells of different sizes. Interestingly, those results brought an end to the human white cell theory since it turned out that the cells didn't have any nuclei. But that's something you definitely see in human white cells and jellyfish as well. These creatures are multicellular organisms whose cells contain nuclei. But what kind of life wouldn't have nuclei? For example, bacteria and some other microorganisms similar to them. An expert working on this mystery said that the blobs had no clearly visible structure, and it didn't appear even when they used a microscope. In the end, the researchers concluded that the substance contained 2 types of bacteria, both found in the digestive tracts of humans and other mammals. They were also often found when waste was deposited. These bacteria could travel in the water and through the air. The goo could be some kind of a carrier system. Unfortunately, the scientists admitted that they didn't have any hard evidence to support their idea. To add to the mystery, the samples reportedly went missing before the researchers could finish their work. But is it true that the weird blobs made people sick? At first sight, yes. A few Oakville residents reported becoming ill and experiencing similar flu-like symptoms after touching the Oakville blobs. But was it a direct consequence? No one knows. Experts admit that the cases of illness could have been a coincidence, which makes the incident even more intriguing. So far, the mystery remains unsolved. Now let's move on to the other stuff falling from the sky. Bad news. Some of it can be totally disgusting. Like worms falling from the sky in China and wiggling on people's cars. Some people thought it was an animal rain, while others were not convinced. They stated that the video was fake since the worms were only on vehicles but not on the ground. Others were sure worm rains were a totally normal thing in March. Ugh, luckily not where I live. But the most shocking thing? Bizarre worm rains happened in the British Isles too. For example, in Scotland, kids were playing soccer when worms started raining down. The reason could be a substantial weather change, or who knows what. But the cases of animal rain actually started long ago. In 1877, an unusual tornado hit a farm in Southern California, bringing along several tiny alligators about 1 foot in length. In 1894, a tornado moved through England, dropping poisonous jellyfish on people's heads. Even though some witnesses claimed those were not jellyfish but tadpoles, the incident was still extremely strange. In 1876, in Kentucky, black humor rain was recorded. That was when chunks of meat fell from the sky. Now, let me tell you, if you're squeamish, you might want to skip this part. Okay, I've warned you. Locals claimed the meat tasted like mutton, but later, researchers discovered that buzzards flying over the area must have felt unwell and regurgitated their meal right in the air. Ew, told ya. All these are instances of the animal rain, a rare meteorological phenomenon in which flightless animals fall from the sky. Such cases have been reported throughout history, starting from 1794, when French soldiers saw toads fall to the ground during heavy rain near the French city of Lille. How do such rains occur? It might be different for different species. For example, frogs and toads often roam the countryside in large numbers. Powerful winds can pick them up and carry them for great distances. Or let's take fish. In 1861, there was a reported rain of fish in Singapore. And a naturalist speculated at that time a migration of walking catfish could be taking place. So the wind might have dragged them over land from one puddle to another, as if they had been following the rain. In any case, the most common explanation of such cases is that there is no actual falling at all. Animals are just driven along by winds or something of the kind. This can also explain why typically only one single species of animal is reported raining from the sky. Another probable explanation involves tornado waterspouts. Those are tornadoes forming over the water. A tornadic waterspout can potentially transport animals to relatively high altitudes and carry them to remote locations. This idea is supported by the suggestion that animal rains are often preceded by storms. At the same time, this theory doesn't explain why each incident involves just one species, not a group of similarly sized animals from the same habitat. Here are some other examples of animal rains. In 1947, fish started falling to the ground in Louisiana. And in 2005, it rained frogs in Serbia. In 2010, a small town in Australia experienced a rain of perches. These occurrences were most likely caused by tornadoes, lifting things from the ground and water and depositing them in totally different areas. Sometimes, even iguanas might fall onto your head. When it's really cold, they go into hibernation mode to survive. But even though they might look frozen, they're still alive. When it gets warmer, they start moving again. But unfortunately, while in that chilled state, they might fall down from trees, which is dangerous both for the animals themselves and for passers-by. A heavy snowstorm rolls in, and then you hear it. A distinct sound of thunder and see lightning sparkling in the sky. Congrats! You're one of the rare people who has witnessed thunder snow. Until recently, scientists couldn't even agree that it's a real thing. But now, as they see more and more videos of it popping up online, they're trying to understand how it forms and how dangerous it really is. One thing is for sure, if you see lightning during a snowstorm, there's at least half a foot of snow falling somewhere nearby. We can even predict heavy snowfalls by thunder snow, but it doesn't work the other way around.
Not every heavy snowfall causes thundersnow, and scientists are still wondering why. They think this beautiful natural event happens in a way that's kind of similar to summer storms. Turbulence in the air makes warm, moist air near the ground rise up into the sky. As it goes up, it cools down and forms clouds filled with tiny ice crystals, supercooled water, and soft hail called graupel. When these things crash around inside the cloud, they create an electrical charge, which leads to lightning and thunder. When it's cold enough for snow, the atmosphere doesn't have as much energy as it does in the summer. That's because the ground doesn't heat up as much in the winter, so there's less warmth and moisture in the air. So, there's less supercooled water in the clouds compared to a summer storm. When the right conditions do occur, it usually happens near the Great Lakes in the United States. In places like this, the cold air above mixes with the warm water from the lakes. This big difference in temperature creates areas where the air rises quickly, and those rising pockets can cause lightning and thunder during heavy lake-effect snowstorms. They're also more common in the Colorado Front Range and Upper Great Plains. Another difference between thundersnow and a regular summer storm is that it's much harder to spot thundersnow. Snow absorbs sound waves, so you can only hear thunder if you're within a few miles of it. It will be more like a low rumble than a loud, sharp bang, and it's harder to see a flash of lightning against the backdrop of a bright white sky filled with flurries. This way, thundersnow can catch you off guard and strike just like any lightning. Although, lightning and thunder that come with a snowstorm are usually less frequent and less intense than those that come with summer storms. So, perhaps the worst thing that comes with thundersnow is those heavy snowfalls that can cause chaos on the roads and leave you without power for days. Another cool and rare winter weather phenomenon is the snow donut. You won't want to eat this donut as it looks like snowy wheels or tires. You can mostly find these rare natural snow shapes in the open prairies of North America or some remote places in Northern Europe. They need the perfect mix of conditions to form. First, there needs to be a layer of wet snow on the ground. The surface has to be something the wet snow can't stick to, like ice or very soft, powdery snow. Then, a strong but gentle wind or gravity on a hill has to push the snow just right. As the snow moves, it rolls up like a carpet and forms a big donut with a hole in the middle. Ever heard of the red lightning called sprites? Unlike regular lightning that strikes down from the clouds to the ground, they shoot up high into the atmosphere, about 50 miles above Earth. They're super fast, lasting just a tiny moment, so they're really hard to spot or study. Sprites happen because of a buildup of electricity in clouds, just like normal lightning. They are usually red and can look like jellyfish or carrots and get up to 30 miles wide. Pilots flying in high-altitude planes get the best views, and you can't see it from the ground. Scientists think sprites could happen on other planets with atmospheres. They tested this idea in a lab by recreating those planets' atmospheres and running electricity through them. It turned out they were right. A fall streak hole is a big circular or oval-shaped gap that sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. They need ice crystals to freeze. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once they're there, the water droplets freeze quickly, get bigger, and start to fall from the cloud. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. A mini tornado that spins up a lot of dust and dirt on a hot day is called a dust devil. They're little whirlwinds filled with dust and debris, and they can happen all over the world. They're smaller and not as strong as tornadoes, but they can still be powerful enough to knock over small objects or lift light things into the air. In really hot desert areas, they can grow much taller and last longer, sometimes for over an hour. Dust devils form on sunny days when the ground gets super hot. Once the dust devil is spinning fast enough, it acts like a chimney, with hot air rising up and cooler air sinking down through the middle. Dust devils can be dangerous if they're strong enough, so it's best to stay out of their way. Have you ever seen a fog bow? They form in a similar way to regular colorful rainbows, but they're much wider. Fog bows are made by tiny droplets in fog or clouds instead of big raindrops like in regular rainbows, but they also appear opposite the sun. You need to look for a fog bow in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean, where fog often forms. Because the water droplets in the fog are so tiny, fog bows don't have the regular bright rainbow colors. They might even look all white or faint. Some fog bows are hard to see at first because they blend into the mist, but once you spot them, they're easy to recognize. There are atmospheric rivers flowing high up in the sky. They're long, thin streams of air in the atmosphere that carry a lot of water vapor. Even though you can't see them, they sometimes hold as much water as the Mississippi River carries in one day. When these sky rivers reach land, the water vapor inside them often turns into rain or snow. Some are gentle and helpful, bringing much-needed water to dry areas. But the really big and powerful ones can cause heavy rainstorms or snowstorms. If they stop moving over certain areas, they can lead to flooding, mudslides, and other problems. One famous atmospheric river is called the Pineapple Express. It gets its name because it pulls warm, wet air all the way from tropical areas near Hawaii to places like the US West Coast. Cumulus clouds are some of the strangest and coolest ones in the sky, looking like big, fluffy pouches or bubbles. Their shape can change a lot. Some look like smooth bubbles and others stretch out like long tubes. Cumulus clouds usually form under big clouds. Inside these storm clouds, strong winds cause turbulence, which pushes air and moisture downward instead of upward like regular clouds. This creates those uneven, pouchy shapes. Because cumulus clouds are connected to powerful storm clouds, they're often a sign of bad weather, like heavy rain, hail, or lightning. In the winter, if it's cold enough, they can sometimes bring snow. Sometimes they appear with other, calmer clouds, but that's pretty rare. The best time to see cumulus clouds is when the sun is low in the sky, like at sunrise or sunset. The sunlight lights up the pouches, making them glow and look even more amazing. We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to Southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the Enso cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication, both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside. If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain, and that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister. and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable, and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters, but areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
June 29th, 1764, seemed like a regular day in one small picturesque town in Germany, Waldeck. Residents were in church. Little did they know that a powerful storm was about to hit the area. It wasn't just an ordinary storm, it was a strong, swirling tornado getting closer and closer. It was an F2 tornado at the beginning, strong enough to uproot trees like oaks and beeches. But as time went by, it grew and became more powerful. It even picked up 2 children on its way and threw them into a lake. Something strange happened too. The water level in the lake rose and then quickly retreated. Leaving the lake behind, the tornado struck a house, tearing off the roof and knocking down the walls. Then the tornado changed direction and headed east-northeast, increasing its intensity to F3 level. That's when something fascinating happened. A possible twin or satellite waterspout merged with the tornado along the shore of Lake Luzin. It was like 2 tornadoes coming together. It got wider and stronger, so it started snapping and uprooting solitary oak trees, flinging them 115 feet into the air. It left behind a barren landscape, removing crops, grass, and even topsoil. Back then, people couldn't even read or write very well, let alone use devices that could predict a tornado. This one was so strong it destroyed houses, barns, and even uprooted trees. Such a terrifying thing to see. But there was something special about the church people were in. It had strong stone walls, so they were safe inside, even though everything outside was getting destroyed. They didn't even realize how lucky they were until later. With winds estimated to be over 300 mph, it was unstoppable. The tornado traveled a distance of 19 miles and stretched to a maximum width of 0.6 miles. A raging storm threw tree branches so high, people believed they ended up in the atmosphere. Another strange thing about this tornado was that it occurred during a dry storm. There was very little rain reported, but the storm still managed to make such a mess. It even produced large hailstones, some as big as 5.9 inches in diameter. Just imagine chunks of ice that large falling from the sky. These hailstones caused significant damage to crops and properties, and everything else that was outside at that time. After the storm passed, one scientist, Gottlob Burchard Gensmer, studied the damage and talked to people who had witnessed the tornado, only to realize this was one of the strongest tornadoes ever recorded in history. It reached F5, the highest rating on what's called the Fujita scale, which measures tornado strength. It took an hour for the madness to stop. Back in 1925, people in northeast Missouri didn't have an organized tornado warning system either. It took them by surprise when one day, in the early afternoon, they saw a tornado forming in that area. At first, it was a small one that briefly lifted off the ground. But as time went by, it started growing into a massive monster. Meanwhile, in West Frankfort, Illinois, some miners were working deep underground, about 500 feet below the surface. Suddenly, the power went out, and they knew something was wrong. They quickly started climbing up the shaft to get to the surface. When they finally made it, they were in for a terrible shock because of the devastating consequences of this giant tornado. The tornado didn't even stop there. It kept on making a mess as it traveled a long distance. It plowed through the land for a whopping 219 miles, all the way from near Redford, Missouri to the east of Princeton, Indiana. It moved at a crazy speed of 73 miles an hour. In one town, Murfreesboro, Illinois, the tornado wiped out a staggering 100 blocks of the town, plus another 70 blocks ended up destroyed by fire. In another town, Griffin, Indiana, not a single building was left standing. The tornado got weaker only at 4:30 in the afternoon. This tornado, known as the Tri-State Tornado, really made history as the worst and longest-lasting tornado ever recorded in the United States. In April 1965, people in the region of the Great Lakes started complaining about this weird heat. The forecast showed no storms for that area. It was because of thunderstorms sweeping across the upper Midwest of the United States. These storms were insane and so powerful they created 51 tornadoes in just 12 hours. The states of Indiana, Ohio, and Michigan ended up being hit particularly hard. Something unfortunate happened during this time. All this caught the forecast team, the National Severe Storms Forecast Center in Kansas City, Missouri, off guard. They quickly tried to send out warnings to let people know what was happening, but many people didn't hear the announcements because there were no outdoor tornado sirens at that time. Additionally, a lot of TV and radio stations didn't regularly broadcast weather alerts. Power was gone, and telephone lines didn't work, which meant many towns were completely cut off from communications. People couldn't receive the warnings because they didn't have access to electricity or working phones. One spring day in 1974 was especially hard because of severe thunderstorms that unleashed a series of powerful tornadoes across 13 states in the United States. These tornadoes lasted for 16 hours, and they ranged from weaker F0 to the most powerful and destructive F5 ones. At one terrifying moment, there were 15 tornadoes touching the ground at the same time. One lasted for more than 2 hours, and 2 others were swirling around each other like dancers. This was another big lesson, after which some changes in tornado warnings were made. In those days, weather forecasters could only warn people about a tornado if they had seen one with their own eyes, which was mostly too late. April 26, 1989, at around 6:30 in the afternoon, the sky above one district, Maniganj in Bangladesh, turned dark and ominous. The tornado began its journey from one point, Daulatpur, and moved swiftly eastward, Saturia, Maniganj Sadar. People living in that region had already been facing a severe drought, and little did they know there were even worse scenarios coming. The storm was fierce, stretching about 10 miles long and 1 mile wide. It covered a relatively small area, but it still caused enormous damage. It tore through the land and blew away buildings, thousands of trees, strong and rooted for years, and everything else in its path. The countryside of Marsala in western Sicily is really beautiful, but it wasn't so stunning on December 8th, 1851. 2 fierce tornadoes suddenly swept across the land, leaving nothing but chaos. As they moved, they brought along heavy rain and hailstorms, causing even more damage to the already vulnerable farmlands. One town, Castellammare, had an amazing harbor with plenty of ships, and it suffered great damage. The news of this devastating event reached far and wide, even making its way to the Illustrated London News. The outbreak in Oklahoma from 24 years ago, May 3rd, 1999, was tough too. Just one stormy day caused enormous damage from Texas all the way up to South Dakota. At least 45 tornadoes touched down, and Oklahoma was hit the hardest with an F5 tornado. The story seemed familiar. What first seemed like a small twister quickly grew into a massive force that, at one point, measured 1 mile in width. This one ripped asphalt from roads, peeling it away in layers like fragile paper. It tore the vegetation away and even wrapped roofing materials around power lines. NASA scientists studied the area using satellites. They realized it would take between 10 to 20 years for the vegetation to fully regrow in the region where the tornado left nothing but muddy, barren land. Oklahoma is in a pretty unfortunate spot when it comes to tornadoes. Take 1947 as an example. The Woodward tornado got named after the city it had struck. This monstrous tornado was massive. It reached 1.8 miles in width, and it raced forward at an incredible speed of around 50 mph. Before reaching Woodward, the tornado had already caused a lot of mess in other towns along its path. But it was in Woodward where it unleashed its worst fury. Without any warning, it struck the city at 8:42 in the evening, catching the residents by surprise. Communication with the outside world was cut off, leaving families uncertain about the fate of their loved ones. As if one tornado isn't enough, some areas get struck by a series of them. In 1908, an outbreak of tornadoes swept across the eastern part of the United States. From Texas to Georgia and then northward from Oklahoma to Tennessee, at least 34 tornadoes touched down. Nature showed no mercy. Buildings were torn apart, and once thriving streets were reduced to rubble. The Fujita scale measures tornado strength based on two things: the speed of the winds and the amount of destruction caused. F5 tornadoes are the strongest, most destructive ones. I mean, some people talk about F6 tornado with winds that could blow at over 300 miles per hour. If this one was passing by, you'd definitely know how Dorothy felt. Luckily, F6 exists only in stories, and Oz is the last place you are likely to end up at.
Welcome to the Spirit of Discovery cruise ship, which will take you on an unforgettable sea voyage around the Canary Islands. The azure endless ocean, delicious food, the highest service, premium cabins, and a terrible nightmare that you will probably remember for the rest of your life. This is exactly how one luxury trip of the Saga Cruises Company ended last year. Instead of relaxing during the cruise, passengers felt fear and horror, and even had health problems. And that's why. On October 24th, the Spirit of Discovery liner started a 2-week cruise around the Canary Islands. There were about 1,500 people on board. About 1,000 were passengers, and the rest were crew members. The first week went great, but then the liner encountered a serious problem called nature. There were strong winds and big waves. The captain decided to return to the UK ahead of time, but the decision was made too late. The ship was caught in a severe storm in the Bay of Biscay. A powerful wind with a force of 11 points hit the vessel. To make it easier for you to understand, the 11-point wind is able to tear out trees together with roots, destroy residential buildings, and plunge entire cities into chaos. Such a storm is rare, but Spirit of Discovery was unlucky enough to get into its epicenter. 11 points is the penultimate place on the Beaufort scale, which determines the wind rating. The most powerful storm has 12 points, and this is a hurricane. The wind reached a speed of 65 miles per hour, which is about the same as the average speed of a car on a highway. Not only did it push the Spirit of Discovery, but it also raised huge waves 25 feet high. Just imagine a wall of water the height of a 3-story building collapsing on a lone ocean liner. At that moment, the captain sent a message to all the passengers through the cabin speakers so that no one left their place. And his voice sounded worried enough. All the passengers had to lie down and hold on tight. According to the witnesses' words, the ship remained caught in the storm for about 15 hours. They held on with all their might so as not to crash into the walls and floor. All this time, tables were flying around the ship, dishes were breaking, furniture was moving all over the cabins. The waves smashed windows, partitions, and doors. Some people were knocked down because they couldn't hold on for so long. The storm hurled the passengers from ceiling to floor, from wall to wall. The ship's crew turned the dining room into a medical area to provide assistance to those who had been hurt. Despite the difficult and terrible conditions, the ship's team did a great job. They regularly informed passengers about the current situation and tried to calm everyone down. There was no panic and chaos on board. When the storm finally ended, the ship continued its journey and finally reached land, where medics urgently evacuated 8 passengers to the hospital. One of them was never able to survive this storm. It's good the ship didn't meet a rogue wave during the storm. This is a natural phenomenon that can appear during a storm and even in still water. It's a giant wave with a height of 60 feet. Like a 6-story house, it collapses onto a ship with incredible speed and capsizes it. And then the wave suddenly disappears. This is no joke. A similar wave has been recorded in the Gulf Stream off of Charleston, South Carolina. It's scary to get in its way. Now, let's go back to the past to remember one of the most terrible maritime tragedies. No, we're not talking about the Titanic. We'll talk about the Greek liner Laconia, which set sail from the English port of Southampton on December 19, 1963, with more than 600 people on board. However, just 3 days later, a terrible tragedy happened to the ship in the boundless waters of the Atlantic. At 11 p.m., in the barbershop hall, an electrical malfunction occurred. The problem led to a fire, which quickly spread to other rooms. The crew couldn't cope with it, since the fire was spreading too fast. The ship's team turned on the fire alarm, but there was no command to leave the vessel. Only 2 hours later, the captain ordered the passengers to evacuate. All this time, people were either relaxing in their cabins or enjoying a party in the ballroom. The crew was probably trying to put out the fire without causing panic. However, when the situation became critical, the evacuation began. People panicked and ran to the lifeboats, but many didn't manage to get inside. One of them was John Morris. He survived this catastrophe and shared his memories of how he put his family in a lifeboat while he stayed on board the ship. He didn't even have a life jacket. Since there was nowhere to go, the ship's crew opened a bar so that people could relax a little. However, at that moment, boilers began to explode inside the ship, and it became clear the vessel wouldn't stay afloat for too long. John Morris decided to jump into the water right in his tuxedo. As soon as he was overboard, he grabbed onto a piece of wooden deck cargo and swam as far away from the ship as he could. The giant liner could sink at any moment, and when such a huge object goes down to the seabed, it forms a water funnel that pulls along everything around. Rescuers arrived at the scene sometime later. Fortunately, John Morris's pregnant wife and young son were alive, but his mother-in-law unfortunately didn't survive the disaster, like many other people that day. Of course, after this incident, the Greek Ministry of Merchant Marine initiated a thorough investigation. For 2 years, they collected information from passengers and the captain, studied the technical characteristics of the ship, and eventually came to certain conclusions. According to them, the ship's crew gave the evacuation order too late. Not all passengers were able to get into lifeboats, but half of those boats remained on board because of the chaos that prevailed during the evacuation. Several officers of the liner were accused of negligence, but the captain and his first mate received the most criticism. As for John Morris, he stated that he felt himself under protection that day. Another unusual story happened on a cruise ship relatively recently. Spoiler alert, the ship didn't sink, there was no evacuation, and the weather was good. However, for many passengers, this journey became a real challenge. Imagine that you've been working for a long time and saving up money to go on your dream trip on the Celebrity Mercury cruise ship in the Caribbean. You arrive in South Carolina, from where the ship begins its journey. You get on board, looking forward to a week's rest. At first, everything is fine. People are having fun, chefs are cooking delicious dishes, and beautiful daytime landscapes turn into night parties. But then suddenly, many passengers start throwing up. Someone is in a hurry to go to the toilet, and someone stays and vomits right in the halls. The cruise turns into chaos. More and more people feel terrible because of unknown poisoning. You also visited the restaurant and eaten seafood, but fortunately, the disease has avoided you, which can't be said for more than 400 other passengers. Almost every 1 in 4 people on board face gastrointestinal problems. There were almost 2,000 people, and a quarter of them are in bad condition. Crew members do endless cleaning. They wash the deck, give people nausea pills, and ask them not to leave the cabin till the illness passes. The captain sends several samples ashore to determine what caused the poisoning. Unfortunately, the cruise is already ruined, and all the passengers have unpleasant memories. So the company organizing the trip issues certificates that can be used on future cruises. It's not the most pleasant experience, but it's still better than nothing. Now, imagine if, instead of just feeling sick, people got infected with some kind of bacterium that would turn them into zombies. It would be much more exciting and scary. Now, do you think you could survive on such a ship full of zombies? And how would you do that? Tell me about it in the comments.
Whoosh! British astronomer Richard Carrington was observing the surface of the sun through his telescope when he suddenly noticed something strange. There were two patches of very bright and white light. It's 1859. People are outside working on their farms, harvesting the fruits of their labor. Life is different, more nature, less technology. Science is developing. Not even a light bulb is invented yet. It will be invented in 20 years, though. Back then, the astronomer didn't know he was looking at what would later be called the Carrington event, the largest solar storm ever recorded. In fact, this was the first solar flare we've ever seen and reported. And there was so much going on. Auroras, the southern and northern lights, were just amazing. They've been more intense in that year than in the last 160 years. Auroras mostly appear near the Earth's poles. But back then, you could see these perfectly illuminated lights in the sky close to both the equator and the poles. They spread across the sky from everywhere from Australia to Canada. If you happen to visit the tropics like Panama, Jamaica, or Cuba, you could also see auroras. It was spectacular. Luminous waves were rolling up as far as the zenith, and some were even big enough to cast a shadow on the ground. And the colorful displays were really bright. If you were in Missouri at that time, you could normally read a book by the atmospheric light even after midnight. The light was so strong that the gold miners that were in the Rocky Mountains just woke up, prepared their bacon and eggs, and made coffee without further questions. They thought the sun had risen on a cloudy morning, even though it was 1 a.m. local time. But this extremely strong solar outburst resulted in electrical disruptions from Boston to Paris too. And the telegraph lines. There was so much electricity in the air, telegraph machines could send messages from Pittsburgh to New York without batteries. In Paris, even sparks flew from telegraph machines. And now, fears are mounting that there's another powerful solar storm coming in 2025. It could cause massive power cuts and blackouts, as well as cut off internet access in entire communities, maybe even for months or years. Today, we depend on electricity way more than we did back then, not only when it comes to gadgets in our homes, but hospitals and other places where technology is simply necessary. Electricity is essential even for food, as we need electricity to store it. We need it for our everyday things like work and communication. Another solar storm as strong as the Carrington event could cause trillions of dollars of damages here on Earth. It would knock out power for up to 40 million people only in the United States for a few years. What are solar flares anyway? They are the biggest explosive events that happen in our solar system. So, magnetic energy builds up in the sun. Bam! When there's an intense burst of that magnetic energy, that's when the solar outburst happens. This throws off whole waves of energy that move and travel outward. Of course, it impacts other bodies in our solar system, including the Earth. And when these electromagnetic waves interact with the magnetic field of our home planet, a few things happen. First, what we get is that electric currents flow in the upper layer of our atmosphere. They heat the air. It's like the Earth gets its own electric blanket. This is the stage where you can see stunning auroras over polar regions. But it's also when GPS and radio signals get disrupted. As our atmosphere heats, it puffs up, similar to a marshmallow. This adds more drag to satellites in low orbit. It means that as the atmosphere expands, it's pushing satellites back down to the surface of our planet. It also knocks small pieces of space junk off their course. As strong electric currents flow through the Earth's upper atmosphere, they affect strong currents that flow through our planet's crust too. This can mess with electrical conductors that sit on top of the crust, like power grids. They make the network that carries electricity from generating stations to buildings and homes. And this results in power outages in certain areas, and this can be hard to fix. For instance, this happened in Quebec in March 1989. A powerful solar flare burst off the sun.
Shortly after that, another burst sent out 1 billion tons of gas directly to our planet. People there experienced a 12-hour blackout. Only a couple of months later, in August, another solar flare burst towards our planet. It was even bigger than the one that occurred in March. It caused damage to microchips across the world and left Quebec in darkness once again. Flares can be more dangerous for the technology we have than for ourselves. In winter 2022, a solar storm knocked a fleet of over 40 Starlink mini-satellites out of orbit. Solar storms often happen at the same time when the sun releases large bubbles of solar material we know as CMEs, or coronal mass ejections. These bubbles can have billions of tons of plasma, which can move at millions of miles per hour. That way, solar storms fire out radiation, whereas CMEs are plasma eruptions. CMEs and solar flares discharge particles and radiation. As they hit the upper part of Earth's atmosphere, they form radio waves. We call them geomagnetic storms. They form new currents and add energy into electrical grids that are usually passive. This way, they threaten to overload them. Take electricity that's coming out of your wall plug as an example. It changes back and forth by about 50 Hz, depending on the country you live in. Radio waves usually broadcast about 85 to 105 million Hz. Gamma rays and X-rays have frequencies of up to 50 quintillion Hz. Solar radiation is the same one your phone uses for power, only a couple billion times stronger and kinda out of control. Researchers believe a powerful solar storm might hit us in 2025. These storms get to their peak, which, by the way, can turn pretty violent, every 11 years. We mostly get lucky because they bypass us, but we can't expect our good fortune to last forever. Now, we have about a 2 to 3% chance for a Carrington-level event to happen in this decade. The shorted electrical grid wouldn't be only a one-time loss. It would take us up to 10 years to recover from something like that. That way, humankind might be set back by nearly 20 years if it happens. All those particles wildly bursting around could cause damage to our satellites. We could lose communications that way. No TV, internet, or GPS. We'd be dealing with very, very strong radiation. There's a possibility people would face some long-term issues because of that. What could such an amount of solar radiation do to our DNA? Especially those that are not protected by the magnetic field of our planet, like astronauts. Humankind can try to protect the internet against the next enormous solar storm. The first thing we can do is to shore up power grids, undersea cables, and satellites against being overloaded. And we can look for methods of predicting such storms in the long run. That's hard because these storms have been happening for millions of years and we've been able to record them for less than a century. Plus, the technology these storms affect is only 2 decades old. At the moment, we can observe the activity of sunspots, which are black patches on the solar surface that tell us it's the area with high plasma activity. And by checking them, we can predict solar storms up to 2 days before they strike our planet. But we can't track them the way we follow hurricanes. Hopefully, we'll be more ready by 2025 to avoid an internetless future. Although, it would be cool to take a break from social media, don't you think?
In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problem for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the Sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies will go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the sun are similar to this tousled hair. When the sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.